Assalamu alaikum students. So my today's topic is geometric mean leg theorem. Now what geometric mean leg theorem is, if you have a right triangle, now in a right triangle we know that these are the two legs and this is the hypotenuse. Why this is the hypotenuse? Because it's opposite the 90 degrees. This is my shorter leg, this is my longer leg. Now if we need to find one of these legs and we are given with the length of the hypotenuse, and one more thing which is given to us is the altitude. If an altitude is dropped in the right triangle, an altitude in the right triangle is dropped from the 90 degree to the hypotenuse. This is my altitude. It makes 90 degree to the hypotenuse. Okay, let's name this S. And if we want to find one of these original legs of the right triangle, what we do is the leg, let's find for instance for this one, the leg of the hypotenuse of the right triangle is the geometric mean of the hypotenuse. So this is the hypotenuse, and the segment which is adjacent to that leg. So the segment which is adjacent to the leg is this one on the hypotenuse. Okay, the length of the leg of the triangle is a geometric mean of the length of the hypotenuse and the segment of the hypotenuse which is adjacent to that leg. Okay, so in this case, if I want to find PQ, it would be PQ squared is equal to, because this is a leg, this is equal to the hypotenuse, which is PR, times the segment of the hypotenuse which is adjacent to this leg, which is PS. Okay, and if we were to find out QR, this leg would be the geometric mean of the hypotenuse, which is PR, and the segment of the hypotenuse, this segment of the hypotenuse which is adjacent to that leg. Okay, so this segment of the hypotenuse. Okay, first the whole hypotenuse times the segment of the hypotenuse which is adjacent to that leg. So in this case, if we were to find QR, it is the geometric mean of PR, the hypotenuse, times SR. This is how we will be finding the leg. This is called the geometric mean leg theorem. So let's complete this statement. The geometric mean leg theorem, the length of the leg of the triangle is geometric mean of the length of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So if we were to find out AB, it will be AB squared is equal to the hypotenuse, which is AC, times the segment of the hypotenuse which is adjacent to that leg. So AC times AD. Okay, and if we were to find this segment leg of the triangle, this leg of the triangle is the geometric mean of the hypotenuse and the segment which is adjacent to that leg. So this is the segment which is adjacent. Adjacent means next to that, close to that. Okay, so in this case, BC squared will be equal to AC times DC, CD or DC, whatever you want to say, DC. Okay, let's do one of the example. So I want to find the leg of the right triangle. Can you see? This is my altitude. So to find the leg, I know leg is the geometric mean of the segment of the hypotenuse. And now I can say my hypotenuse is 26 because 24 plus 2 is 26. So it will be 26 here to times the segment which is adjacent to that leg. So this segment, 24 times 26. So my x squared is equals to 624, and my x, taking the square root, my x would be 4 square root 39. This is the length of my leg. Okay, I'm going to do one more question, 15. In question 15, they gave you a triangle and they're asking you to find multiple sides. Okay, so first of all, I want to know which is my original right triangle. I can see this is my original right triangle and this is my altitude. Okay, so I need to find both of the legs. What I know is the altitude here. Okay, so I can apply my altitude theorem, and according to my altitude theorem, a geometric mean altitude theorem says my altitude is the geometric mean of the two segments where it is dropped. So to find x, I'm going to apply the altitude theorem. It says 8 squared, altitude is the geometric mean of x times 20. So 64 equals 20x. To find x, I'm going to do 64 divided by 20 gives me x equals 3.2. Now once I know this 3.2, I can find y and z because these are the legs of my right triangle. Okay, let's find out y. Y, I know that this is the leg of my right triangle. The leg of the right triangle is the geometric mean of the hypotenuse times the segment adjacent to that leg. So this is the segment adjacent to this leg. So my y squared will be equal to the hypotenuse. What is the length of the hypotenuse? 20 plus 3.2, because this is the whole length, which gives me 23.2. So the hypotenuse times 20, right? (23.2) times 20, and my y will be equal to, y squared will be equal to 464, and then y is 21.5. Now let's find out z. You can also find out y by applying the Pythagoras theorem. You can see this right triangle, right? A squared plus b squared equals to c squared. Okay, and now for z, I know this is one of the leg. I know this is making 90 degrees. I can apply the Pythagoras theorem here also, but let's find out, because I know the altitude. Once I didn't know the altitude, then I have to apply the leg theorem. Let's apply the leg theorem here, which says that the leg of the right triangle is the geometric mean of the hypotenuse, which is 23.2, times the segment which is adjacent to it, and the segment adjacent to it is 3.2. So z squared is equals to 72.724, and z is 8.6. I hope you understand the question. Assalamu alaikum.